Good morning. Good morning, good afternoon, good evening. It's another Wednesday, another episode of our weekly technical forum sponsored by Love My Tool. And today our rotation is back to Paul Offord again. And Paul is not at home actually. He's actually working this week. But he has some interesting stuff that he wants to talk about. So when you have a good technical panel such as we have today with Paul and Tony. Hi Tony.
Hello, hello, hello.
Hi Tim. Hi Tim.
Good morning, everybody.
When you have a good technical panel such as you have today, you learn to just not say too much. So I'm going to turn this over to Paul as quickly as I can. Hi Paul. Why don't you take over and it seems like you have some very interesting stuff to talk about.
I hope so. So it's a very recent problem that we've been looking at, and it's quite topical, so I thought I'd share it with you. Let me just share my screen correctly. Okay, hopefully you can see my slides.
It's perfect.
Yep, so we're going to talk about using a network trace to identify a problem with a mobile banking application. So that's our subject. Obviously, I guess there's probably no one who's watching this show today who hasn't heard about all the controversy regarding iOS 8 and the new iPhone from Apple. And with this as the backdrop over the last couple of weeks, one of our customers started to receive calls from users using a mobile banking application saying that they were using their new iPhone and they couldn't use the banking application. So obviously the immediate assumption is, oh well, it's another iOS 8 problem. So let's just take a look at that for a minute. So the issues they had was that intermittently they couldn't log in. In fact, more times they couldn't log in more times than they could, and also similarly with making payments through the phone. Quite bizarrely, the phone would work fine on cellular internet, but it wouldn't work on Wi-Fi. So it was a very specific type of problem. The setup of the system looked like this. We have the phone, we have a connection through to some servers called Oracle Glassfish servers, which are web service type application servers, and then there were lots of back-end servers. What I'm showing here is quite heavily simplified. I'm sure you can appreciate there's an awful lot of firewalls involved here that I'm not showing. But what we do have is we have SSL traffic flowing from the phone to the F5, and then we have another SSL connection from the F5, sorry, the F5 is a load balancer, I should explain, from the F5 load balancer to the Glassfish application servers. So into this environment, what we did was we added some network tracing. We used a single analyzer with two network interfaces running Wireshark dump cap, and we captured data on the outside and on the inside interface of the load balancer, the F5. Now, because as I'm sure you can appreciate, the sensitivity of this, the traffic is encrypted using SSL, but to give us some visibility into that traffic, we also used logs from the Glassfish server. So that enabled us to get some idea. We couldn't see any confidential information, but what we could see was method calls that were made using the HTTP protocol. So that gave us a bit of an insight. So the situation was that the application worked fine on an iOS 7 phone or an iPad. It was exactly the same application used for iOS 7 and iOS 8, and exactly the same servers were being used. So everything seemed to be the same except for this change in operating system on the phone. So let's take a look at the network trace on the outside of the load balancer. I've I've anonymized this to a certain extent. I've made some changes to it, and I've had to redact some of the information, and obviously there's some things I can't show you, but it doesn't really affect us in our analysis of this sort of problem. So we can see that we've got the phone creating the connection to the load balancer. I should explain this address, the destination address of the load balancer. We've already passed through one firewall that has done some network address translation. So that's why we've got a private address in the packet. So we see the connection being made with the SYN and the SYN-ACK. Now I've got lots of packets in here. Some of them have no actual data content. They're what I refer to as a standalone acknowledgement. It's just an ACK packet with no data. Now I don't really want to look at that information right now, so I'm going to simplify this trace by filtering it. So I filtered to say that I want to see everything that actually is carrying some payload. So we've got a TCP length of greater than 0, but also I want to see the starts of connections and the ends of connections. So I've added in a few additional things here. And apply that, and now what I can see is I can see the connection starting, I can see the SSL handshake taking place, and then I see the first data packet coming from the phone heading towards the Glassfish servers. Now, I've obviously got a trace on the outside of the load balancer and one on the inside of the load balancer, and it's very useful to understand the relationship between those two. Now, I could do that just by flipping backwards and forwards between the traces, but what I prefer to do is drag that information into Excel to help me visualize what's going on. So I simply export this data into a CSV and then open it in Excel, and then I mess around with it and make it look pretty and all those sorts of things. And what that gives me is a spreadsheet that looks like this. And what I have on the left-hand side, I have the traffic on the outside of the F5, and then on the right-hand side, I have the traffic on the inside of the F5. And we can see just the same information. See the connection being made, the SSL handshake, the first packet that's flowing from the phone towards the Glassfish servers, and that causes the load balancer to create a session with one of the servers. That session kicks in. We see the corresponding same data flow at this point here, going from the phone. We've got another level of natting going on here, by the way, but it's going from the phone to the Glassfish server, and then the Glassfish server responds with 2 packets. Those 2 packets then pass back across the F5 and head back towards the phone. So that all is working okay at that point. But then we see this message here, and at this point the user has interacted with the phone, and 5 seconds later we see a packet coming from the phone heading towards the Glassfish server. That packet crosses the F5 just here, and then the Glassfish server responds with a FIN. A FIN means I'm closing the connection. Now, when you're using the HTTP protocol, you always see requests and responses in pairs. So what I should see is I should see, just as I saw here, a request followed by a response. I should see a request followed by a response. But that's not what I see. I see a request and I see a FIN packet. And the Glassfish server should never do that. So when we presented this information to Oracle, they said, fair cop, we're bang to rights and all those things. And yes, there is a bug there, and we'll go off and look at it and we'll fix the bug. So with some fairly straightforward analysis, we've been able to find a problem with an Oracle application server just using some simple packet analysis. So the observations I think that we can draw from this are, the first thing, it's no good you trying to fix problems using anecdote. You know, there's all these iOS 8 problems out there, but what you really need is some proof. And while we were investigating this problem, lots of people were bombarding us with links to forum entries that said, here's another problem with iOS 8, and here's another problem with iOS 8. But none of that makes any difference. What you really need is some real proof. I hope that it demonstrates the power of packet analysis. I guess everybody on this who watches this show would buy into that anyway, so perhaps I'm preaching to the converted there. I wasn't able to show you the logs because there's some information in there that I prefer not to show you, but using the combination of the logs and the traces, I was able to overcome some of the challenges with encryption so that I could get the visibility into what was contained in those packets. And so if you're a network engineer and you're looking at encrypted traces, go off and see if you can find some logs to match up to those trace entries. And the other thing is, whenever you hear the phrase, that doesn't explain why, which, you know, I'm looking at evidence of a Glassfish server problem here, the obvious retort to that is, that doesn't explain why I don't get the same problem with iOS 7. Well, actually, it turns out that when you do the analysis of iOS 7, it doesn't work in quite the same way. There's a very subtle difference in the way it works, and that's why you don't get the problem. It's not because the problem doesn't exist in Glassfish. The problem is most definitely there, but iOS 7 is slightly different. So I think at that point, I can bail out and hand back over to you guys if I can just stop my screen share. Sort that
I
out.
heard last week I got an email from Barclays and BBT in the United States, and both of them are experiencing the same kind of problem. It comes back on Barclays as invalid password. BB&T just has a session just flushes and doesn't tell you anything, so you basically start over.
Okay.
So it
but
is.
I tell you what the subtle difference is between iOS 7 and iOS 8, which is probably tripping up many people, is iOS 7 actually very subtly breaks some rules that are defined in HTTP. In that, what happens is that iOS 7, you see the same pattern of trace activity, but the iOS 7 phone retries the operation without any intervention from the application. Now, it should retry it on GET requests, but this is a POST request, and you're not supposed to, the HTTP client should not retry POSTs, because the danger is if you don't have a safety mechanism in there, for example, in a banking environment, you could end up making double transactions. Now, it just so happens that this application is pretty robust, and it's got some other checking in it that stops that happening. So the rule is in HTTP, if you send a post and you get this situation arising, don't retry it because it's too dangerous. And what iOS 7 does is it does retry the operation. So iOS 7 gets around the whole problem by breaking the rules. In iOS 8, it's tightened up on those rules and it no longer breaks those rules. But unfortunately, that breaks the application. So,
well, I mean, also, yeah, one of the things we also found out was iOS, the latest iOS has changed the way it interacts with IPv6, and it uses randomizing MAC addresses. It randomizes it in there like you would in a neighborhood connection in IPv6. So it's another example of people turning on certain things to support a protocol that doesn't work anymore yet, and it's causing some issues there.
Okay. Well, I'm really glad there wasn't an IPv6 aspect to this, because that would have totally stumped me.
Tony, you have any comment?
Yeah, I wanted to. First, I just want to thank Paul for that. That was done brilliantly. I think the big thing that was almost glossed over because it was done so flawlessly was the natting portion of that troubleshooting exercise.
Yeah.
You know, when you have addresses that change, either IP, MAC, or port number, you need a way to figure out how to find it on the other end. There's a lot of jobs I've been on where that process just ends there. and they say, well, we can't see it. Strike one, it's natted, and strike two, it's encrypted. We're out of luck. And the answer is typically, no, there's got to be a way. So again, hats off to Paul for doing that so seamlessly. But natting,
how did you do it?
And that's just it, because usually there's always that subtle hint and trick, and I was going to ask Paul how he did that.
All right, I'll tell you what the trick was, and this comes back again to the web logs. In the web logs, we had exported information, and exported information shows you the original IP address of the device. And so I went to the log, found the IP address in the log, and then mapped that back to the trace entries. Great question, though. Really good.
But that's the thing, though. These days, there's a lot of stuff that is being encrypted for reasons we're not going to get into yet. But the other thing, there's a lot of stuff being natted because of, Tim's written an article about IPv4 and IPv6 and the exhaustion of IP addresses and all that. So it's I'm finding it's becoming more of a commonplace to run into natting and encryption as a combo. VPN or SSL, it's irrelevant. But it was done. It's a good set of skills to have moving forward, regardless of the tool.
Of course, the thing that we do ask, although we never get the luxury, is we ask for the key. Can we have the private SSL key?
Yeah.
I think out of all the times we've asked, I think we've been given it probably twice ever. So, it's that's not something you can normally get hold of. So you need to find other ways, and the other way for us is most definitely to make use of the web logs. Web access logs are a great source of information, and there are all sorts of options that you can switch on inside the web logs, additional information. So you can ask them to switch that on temporarily to get you things like exported information and other sorts of things.
And I think this whole natting exercise goes into a whole other point that I'll just bring up briefly. There's a lot of tools out there that profess to be able to combine flows of information, but again, when you nat and addresses change, then they lose the ability to correlate that. And this is where I always say, the carbon interface, the human, in this case Paul and his team, they have to manually figure that out, find that correlation, find that relationship, and then you're able to pull that apart, because I can tell you right now, there's a handful of vendors that I work with that provide correlation apps and performance measurement stuff. But as soon as they hit some kind of natting, the natting itself will mess them up. But then you put encryption on it, forget it. Then people just shake their heads and say, now what?
Yeah, absolutely. And I mean, in these sorts of environments, like in a finance environment, it's not uncommon to have 3 sets of firewalls with, say, 2 tiers of natting. I mean, we get some incredibly complicated setups, and you're right, matching up all the traces is a nightmare. And you sometimes have to resort to things like using packet lengths and things. And you probably didn't notice as I went through the demonstration, but the packet lengths didn't quite match either, because the load balancer was adding on some additional header information.
Right.
So that makes it even worse. Luckily, there's like for most of the packets, there's a fixed 32-byte overhead, I think it is, or something that you see repeatedly as you go through the traces. But this is just making it really difficult for everyone. But yeah, so web logs I love web logs. Great place to find information. Combining that sort of information with network traces can give you some real insight into what's going on. Of course, the challenge then is the synchronization of the timestamping on your network trace with your web logs, which is the next challenge you face.
But the one thing you really showed here, Paul, is that a consistent methodology, is how you solve problems. You don't randomize, jump here, run over there, change instruments. You just set a process, learn that process, and move forward. And that's a big thing, because a lot of people, most don't have that. They just kind of, let's grab a trace file. What are we looking for? I don't know.
Yeah.
And if you don't see something you understand, move it.
Yeah. No, it's true.
Yeah. But with the
I guess
consistent process works well.
my last, I guess the last question was, in these types of environments or problems, when you find those bugs, I'll just call them a bug right now. Was there any vendor suggestion on a workaround for these guys, or is it just wait for us to dream something up?
No, actually, we, with Advanced 7 working in conjunction with the customer, we did come up with a workaround, and the workaround was this situation only arises when you have HTTP Keep Alive active. And what we came up with was a way of limiting the way Keep Alive worked. You remember I told you that there was about a 5-second delay between one packet and then the next packet. The second packet is using the same session because it's a persistent session as defined by HTTP 1.1 without getting too geeky. And what we did was we managed to find a way of changing parameters on the Glassfish server to limit that. And so what happens is actually the subsequent request from the user after they've interacted with the app actually goes on another connection and the problem doesn't arise. So that workaround is currently being tested, soak tested in their test environment. Once they're happy with that, I think they'll go live with that. Interestingly, the performance impact was not measurable. They haven't been able to detect any form of performance impact with making that change. So that all sounds good.
Oh, slick. Thanks. That was good to know.
Yeah. Okay.
That was
short and sweet. Usually I run on way too long.
No, I feel like I just watched another episode of Sherlock Holmes.
Yeah.
I love
Well,
it.
that's the way it is. You have to think around these things. You know, just as Tony said, you get faced with these challenges when you're troubleshooting, and you just have to step outside of it and think, is there another way of doing this? So much of what I do in terms of the types of problems I end up troubleshooting really is based on these patterns, just looking at patterns of traffic. You know, I know that most applications work in this request response mode, and if I see a request going in one direction and I don't see a response, immediately alarm bells start ringing, and that's without me looking at what the packet actually contains. You know, so it's sort of taking that sort of top level view and gradually drilling down into the data.
Mm-hmm.
So the challenge
you have any comments you want to make?
Sorry, me.
Tim?
Oh, Tim, I'm sorry. I didn't hear anything. I just heard comments you want to make. I thought Paul was going to make one. No, I think, like I said, the great thing about what Paul just presented is this process. You know, if you have a consistent process, Tony, you do it too. You know, you got a consistent process when you're working on troubles. It allows you to eliminate the things that are obviously not wrong and find the things that are divergent. And that is something every analyst must know. And you think about Paul, he goes into a different network, and Tony, they go into different networks all the time without a standardized process, starting from the bottom working up. You just wind up running everywhere and not finding anything.
Yeah.
Yeah. Hey, before we close, we actually managed to do a half-hour show today. It's amazing. But I want to have before we close, I like to do a shout out to some of our sponsors. You know, one of the reasons that we created this LMTV forum is to not only allow our writers and other avenues to present the technical material, but also to our sponsors. In sort of marketing and their products, and also in helping them with brand building. And I think one of the things that my experience in running my last company, my experience is that we often overlook the power of a case study. You know, Paul and Tony and Paul, they come from the service, the sort of expert, the network expert consulting side. Tim and I are our background are more in the vendor side, and we know that vendors tend to like to present features. You know, when you ask them to present an LMTV, they just love to jump into features and show you live demo and all that. But actually, it turns out that one of the most powerful way of selling your product is, in fact, case study. This is actually, I remember when I was running my company, I had to kind of undo the mentality of the sales staff, because typically when you get a meeting with the potential customer, the sales guys want to just go into the conference room, open up the laptop, you know, bring up the PowerPoint and just start talking about the product. And I often have to tell them that I said, actually, the customers, I mean, nowadays customers are so busy that by the time they actually invite you into the conference room, they more or less already know what your product can do. They more or less already know that. This is not like the old days where a salesman would camp out in the lobby and find some time and to go in and just, you know, do a cold call like that. Nowadays, with internet, you have to assume that your customers know a little bit about your product, and chances are they know a little bit about your competitor's product as well. And my experience is that the best way to engage a customer is actually with case study. One of the things that people don't understand is that the best way to build a relationship with your customer, at least especially with the first meeting, is to assure them they're not alone. The customers tend to be, they tend to have this feeling that they're alone, they're fighting a lone battle, right? They don't actually understand that the problem is actually very common, that you as a salesman actually have seen it before. And the thing that the best way to actually build that relationship, to build that rapport with your customer, is to show them that you have seen that problem before, and help is on the way, right? So just starting the presentation with a case study, my experience is the best way to really engage your customer. Do you have that experience too, Tim?
Absolutely. I've never been a person walk in and say, let me show you. I have a story I told years ago, and I've told it a million times. Is I had a salesperson I was going on a call with, and she said, don't worry, this is just me, because I was the technical guy. And I said, okay. And so we walked in this building. She threw the product open, did an incredible demo. And the guy said, well, that's great. I happen to own 7 Ethernet sniffers. What I wanted to talk about was a WAN sniffer. And he just wanted to order one and wanted to know when he could get it and what kind of options he needed. He didn't want to go through a demo. But so first off, I tell people all the time, if you're going to be involved in sales, ask people what the problem is.
Yeah, that's right.
That's right. Join them. Let them know you're not, like you said, Danny, they're not the only one that's got that problem. Okay?
Yeah.
And then if they want you to show them how to visualize it or look at it or fix it, that's a whole different issue.
Right.
But it's I despise personally, and I get called in by companies now to. Actually, this is something new that just started happening. People call me and say, we're looking to buy something that'll do this. Would you go through the industry, take a look, and tell us which one we should be talking to? And then they only invite those people in. They don't do the typical bring in 15 vendors and everybody tell me how beautiful it is and how wonderful it is. They actually pay me now and other people, and I'm encouraging this because, you know, you want people that know what the real world demands. You don't want to just run out there and shake hands with everybody out there. It just and people are getting very economical with their time, like you pointed out. I mean, they don't want to hear from 35 vendors. That's why they sick them on me. But and I'm such a sweet person. I'll listen to them for a minute.
So Paul, I just want you to know that you might not have realized that, but you just got me thinking that this is another genre that we can create for LMTV. That Tim and I can go back and invite all our sponsors and potential sponsors and say, hey, you know, here are the things that we can do for you. We can interview your CEO. We can ask you to do a live demo. We can take one of your technical papers and present in a video form. And in addition, you know, we could also do some case studies. This is really the best way to sell your product. So thank you for that.
Okay.
Okay. So with that,
and these one last thing. These case studies are incredible. Everybody learns from watching a case study.
Yeah. And my experience in selling into the enterprise is that it really doesn't matter what the storefront look like. It doesn't really matter if they sell, iPhone. If every company basically have the same network, right?
Yeah.
It really doesn't matter what they do with it.
Yeah.
They all have the same network. So a case study in one industry works just as well for a case study for a customer in a different industry. It's very, very powerful. Very, very powerful. So with that, we're going to close the show. Thanks again, Paul. Thank you, Tony, for coming.
Welcome.
And have fun in London.
Thank you.
Now stay away from the pubs. We thought Denny and I were worried the other day we couldn't reach out. I told him he's in some pub somewhere and probably fell in the Thames.
You're obsessed with pubs.
Oh, I love pubs. Ah.
So with that, we'll bid goodbye and see you next week. And thanks again, everyone. Thanks, Tony.
You're welcome.
Okay. Bye-bye.
Hang on, Tony.